In this video, we're going to review Newton's second law in terms of momentum. Now, we are used to thinking of Newton's second law as force is equal to mass times acceleration. This is the net force equal to the mass of the object times its acceleration. But there is a more general form, of course. And that more general form is that the force, the net force on an object, is equal to the time derivative of the momentum of that object. And here, momentum is p, so momentum is equal to the mass times the velocity of the object. And our vector F here is the net external force acting on that object. So what does this equation say? This equation says that the net force on an object equals the rate of change of momentum. And where do we need this more general form? Well, this more general form is cases when, for instance, the mass of the object changes during the period of time that we're interested in. An example of that would be if you have a rocket which is burning fuel as it travels. The mass of the rocket is therefore changing over time, and so you have to account for that in calculating its acceleration or looking at its momentum. On the other hand, if the mass is constant, then we can just plug in our definition of momentum here, mass times velocity, and since mass is constant, it just goes to the outside of our derivative, and we end back up with mass times acceleration. So the sum of external forces, the net external force on an object is equal to its mass times its acceleration.